Swayam Prabha. Digital India. Educated India.
Welcome students in our journey to learn about mine closure and sustainability planning. We are today going to discuss about physical and chemical stability issues. And one thing should be clear to you that we are, as a planner, must have a general understanding of a wide spectrum of phenomena which may affect the area where you are doing the planning. So, planning is a procedure, and in that procedure you will have to apply all potential situations. So, for that, when we are going for a sustainable post mining environment care, we will have to plan to see that the physical and chemical stability issues are taken care of. Now, that is, as a post mining mine site care is basically after the mining is over, when nobody will be there to take care of the situations. At that time, the nature by itself should be able to withstand to certain extent the disturbing forces that may be occurring. So, that means we will have to maintain a stability. This stability of the ecosystem there, that is whatever is existing there as a life supporting, as a your environmental conditions, their stability is required, so that the natural system by itself has got its self regulating mechanism, which that will be maintaining a balance, a steady state. So, that is where exactly we will have to focus on while designing or while you're recommending certain activities in the post mining site. So, there will be the environmental systems should be stable. That is exactly that whenever there is any changing forces, any disturbing forces, if it comes, then it maintains a equilibrium, so that the system itself come back to its original conditions, or it is capable of withstanding the disturbing conditions. So, that is why it could be having your physical and chemical stability are to be looked into. So, we can design when we know that what are the factors that can affect the stability, and in your studies for mining and then studies for mineral processing, you have already studied that how you want to do a design a pit slope, design a overburden dump slope. You also knew how to design a tailing dam, also that how will you exactly dispose the chemicals over there. So, that is your STP, ETP, all these things are studied at different courses in your curriculum. But today we will be knowing that considering those factors when you design, what type of landscape you will be producing after the mine closure. That is why that stability, mine site stability design is basically you will have to take care of by properly landscaping. That landscape planning and landscape design will have to be done maintaining the chemical and physical stability. So, in today's lecture, I hope you will be able to identify the factors that affect the physical and chemical stability of the post mining site, and at the end of this you will be able to explain that why we need post mining landscape design, and then the basic objectives of that you can identify that what type of study you should undertake. So, you can undertake some case studies of post-mining site management, and that case studies you will have to study certain what type of disasters have taken place, what type of incidents or accidents have taken place across the world, and how people have reported, and what type of research activities have been taken or undertaken in different mining sites, so that you can identify whenever you go to any Indian mining site that where we are lacking. There are many places in our Indian mining conditions that our post mining landscape design and that stability management has got lot of work to be done. So, saying that the physical and chemical stability issues, you must know that the post mining site will be having some mining and processing waste, there will be residual structures, and there will be mined out structures, the peat, the benches, these are the mined out structures. Even the overburden dump, the way you have formed a heap, that is also a mining structure. So, now in these structures you can have a different type of waste disposal system. When you make a open pit, you have got the waste piles, dumps. If you are having a hilltop, you can fill up the ridges, and then there could be the dump over there. There could be the tailing pond where you can keep it over there. There could be a concentrator or thickener. From here you may bring a slurry pipeline to fill this tailing dams, and there could be a, you have got embankment, you have given and structured this bank, a dam is created over here. There may be underground activities where you might have kept a lot of void, or which may be intervening your water resources, and all these situations may be there. Now, each of that can lead to certain instability. This tailing dam, this dam may collapse, your this materials which you have kept, it may get slided down, then this whatever you will be putting over here, this water, they may sometimes, because of rain and all that thing, it can go overflow, and then it may come out over there. Or if this particular slope get collapsed, then whole material will be coming over here, and if there is already water, that water and slush or mud, this may just overspill and then bury the whole area. So, there is a lot of situation under which a instability, very difficult situation may arise. And then the chemical stability of that area, it is the resistance to attachment by chemical actions. In material science, a chemical substance is said to be stable if it is not particularly reactive in the environment during normal use. So, wherever these materials you are keeping, that how they may be, what type of they may be reactive, if they spill and come over here, that the whole soil can be destroyed. If these particles which can be exactly moved from here because of the wind or because of rain, now these particles, their chemical properties, if the rainwater coming over here, the water while it is percolating down, it can become a toxic, it may go to the water table, and then the water may become undrinkable. Similarly, the soil may be having lot of heavy ions can migrate from here, and they may give rise to your, it go to the food chain and affect your health. So, the chemical that properties of this material, if it is having those type of toxicity, we will have to retain it, we will have to see that they are stable, they do not migrate, they do not move from one place to the another. So, these are the chemical stability, means that whatever that way you want to keep it, you will have to keep it over there, and over the years that should be normal and it should not get affect human health. But always it does not take place. In many mining sites, things have happened, the tailing dam disasters across the world, many such things. This is in Canada, there was in 2018 a break of tailing dam. In India also, you may be knowing about the Lakia dam disaster, which was in Kudremukh iron ore mine, that your dam got collapsed and it created. Also, you might have heard about in near Ranchi in Muri, that is your and the Hindal coast, this bauxite, that alumina plants, they are all mud, red muds, they got spilled over there. this took place. Similarly, many places then the situation become unstable. Now, if this type of disasters to be avoided in the post mining mine site, but there is a issue which can, after the mine is closed, then after 10 years, 20 years, 50 years, such type of problems may take place. This instability in Stukikamata mines in Chile, that was a big disasters when the overburden kept dumped over there, they collapsed, and then the school below that overburden dump, it got buried, killing all the children over there. So that's why that apparently when it looks stable, but we do not know unless and until we properly study. So the stability study is a very, very important issue. So you can see another example of this, what happened in Brazil. This was a iron ore tailings were there, and then when it just the tailing them break, and the whole villages, that more than 134 people died, that 199 people that were reported missing, hardly they could have been found. That happened. A similar type of situations happened in our Goa mines also. And then there are many places, like as for example the tailings of the Sukinda chromite mines of Tata Steel. The type of dam it is there, which is a above the ground tailing dam. It has been very well designed, it is monitored, but if we do not monitor and if we do not keep a track of its stability, that in future that may also collapse. So that's why wherever it is working well, there also you cannot, but you will have to take certain actions so that its stability is maintained. So the physical stability of the site is ability to remain physically unchanged, so that it should not collapse and give life to things. Now, after the mining, that you can see that the site is very unstable here, because unstable means that particles will be moving around. This such type of situation, if it is kept, they will be vulnerable for wind erosion, for your this that is under the rainwater, there will be gully formations, there will be this silt, and your fines will be all migrating from that place. But it can be a stable site can be designed. This is which has been designed and constructed. Now when they have given this grass cover and all, there will not be any wind erosion here. So you can imagine that it is possible when we have done the mining, after that this post mining mine site care must be taken, so that you will have to go for a landform reconstruction, so that they just after the minerals are taken out, the mining work is not over. So that is where exactly your sustainability planning and your mine closure planning will have to be done, and these activities will have to be done with the economic aspects of it. That's why during the mining you have kept this that your escrow fund and all, and I have been repeatedly telling you to do further research, that whatever the escrow fund has been kept in India is a meager, very minimal. With that we cannot ascertain the post mining sustainability. For that we will have to do a lot of work. For this landform constructions, it is for the physical stability of the site to remain the physically unchanged. That exactly the matter which is of concern is the soil surface, dams, pits and water courses, because that the water course, the rivers, the rivulets, the nallas which are there, if they get destroyed, then it has got a far reaching impact. So that's why there will have to be a required physical changes. We'll have to do the landscaping, stabilizing and enhancing uses, that whatever way it is being used, we will have to enhance this use. If you are having that your small rivulets, that rivulet should not cause your flood. So whether this your some of the overburden dams and materials can be used for creating an embankment, so that there is not going to be flood, because near a mining site, if there is a rivulet or any river, definitely from the mining area lot of silt and suspended load will be more. And that's why if there is if any high flood time, if it is going to that river bed, river water goes flooded, the nearby area will be getting all those suspended material. That's why the bank creation is a job which will have to be done for maintaining or keeping the stability of the neighboring area. So, that avoidable changes, that means whatever the erosions, slides on the ground movement, whatever is happening, going to happen, that can be avoided by proper planning. So, that soil surface, that is which is there over the mining land, at the previous figure I showed you have seen, the after the mining it is a barren land, and on that whatever the top layer is there, though we say it is a soil, but exactly in the true sense it is not a proper soil, because there may not be having the organic carbon, there will not be having nutrient, or it may not be supportive to the vegetation. So, but it is the loose top cover of the earth, so which exactly having mainly inorganic material there. Because of the organic matter is not there, they will not be supporting this, and there could be entrapped gas, entrapped liquid, those things could be there. But this soil will have to be exactly made stable and made life supportive, and for that this soil quality, this is not always stable and they will be degrading. So, that is why to maintain a stable soil quality as a proper soil quality, you will have to keep on amending that soil, and that amending, it is exactly how it will be binding, whether that even whatever the left with after the soil, say for example the surface of a overburden dump, it may not be suitable for construction of a road, because that soil, whatever that material, earth material which is there in the overburden, they do not have the bonding between them. There that is your the angle of internal friction, that will be so that it is not at all supportive to holding them together, cohesion is not there. So, in that case you may mix sometimes even this your fly ash, or even sometimes other your sweet soil and cement, or even a cow dung and soil mix will be used over there, so that the bonding property increases, and then you can create a road over there to go. So, there are number of issues that could be looked into, that how the soil stability will be improved. But one thing is there, that for the post mining site, your material that earth surface which is there is not yet soil, because there is a organic matters are less, and as a result to do any vegetations and things like that, you will have to add some organic matter. And that is why we talk about the mulching. By proper use of mulching, by bringing lot of this your say that whatever we see that in the Punjab and Haryana, they burn those haze, and then which create a lot of pollution problem. But there could be a grinder, or that is those haze will be very finely crushed, and that should be brought to the all mining area, and if they are sprayed over there and then allowed to rot and allowed to this, they will enrich, and we can have million of hectares of our barren mine land can become a productive agricultural and horticultural land. So, that is why when we talk of that this environmental management, or that the Delhi to be made free of smog, that Delhi can be made free from smog if all the haze and this your rice straws and this that the residue, agricultural residue which are being burnt in Haryana and Punjab can be brought to the all post mining mine sites for mine site restoration, for stabilizing the soil over there. So, the post mining mine site is often has unstable soil, and that is why this will have to take that your how you can stop the wind erosion and rain erosion. And for that there are different type of wind erosion may take place. There may be a surface creep, that is your that where very fine particles, that is your 0.5 millimeter to 2 millimeter diameter, those particles will be taken away by wind. So, this causes them to collide with the and dislodge. Then when such particles start moving over the over the surface, they will further exactly create some dust, then which can also be taken out, and that is why near the mining area, this because of the surface creep, more fine get generated, and then you go on your suspended solid particulate matter in the air increases. There is also another process of wind erosion called saltation, that is where medium sized particles of 0.05 millimeter to 0.5 millimeter diameter, those particles are lifted off by the air and then it takes over there, and then but they get deposited after some distance. So that is why if there is a mining site, by the side of it in their colony, you cannot keep your clothes outside, because all these saltation products of wind erosion, they come and get deposited on your courtyards. Then the suspended one is finer particles, they get over there and they get carried away by the wind and it can go travel farther. So this wind erosion, by which exactly that instability of the soil, that has led to this, and they have got a different impact. You have studied in the that is your air pollutions, that how it affects our lungs, how people get suffer, and how total disasters. The other thing is that your dumps, when you are putting the overburden dumps, they have got a lot of these factors by which their stability can be affected. That is what type of dump you have designed, their height, their slope, how the materials have been zoned, and then what are the potential surface, how it may fail. Those are the factors that is exactly will be affecting that location, how you have placed it over there, where you have placed the overburden, whether the ground on which you have placed the overburden are that having a proper bearing capacity to withstand that load. If not, will they be heaving up at a distance place. So that is, the foundation should be of proper strength. That is how much what type of soil over which you have kept, what are their moisture content, is there any minerals below that where you have thought of storing your overburden. Then the overburden materials, how their grain size, how the size distributions, they will be affecting the stability, or how the particle may move, how the particle will be carried away by wind, water, or there will be a disturbing conditions by which the stability may be affected. So the groundwater is another factor, and is below how it is there, and that what is the climatic conditions, how the rainfall is coming, and also the method of mining what you are following, because the way you are placing the dump material over there, whether you are placing it layer by layer or you are making it an obliquely making a layer. So the process, the method by which you are developing, and what was the original topography on which you have placed the material, all will affect how this stability will have to be maintained. So then this the composition of the dump and the materials properties, their grain size, their compressive strength, their shear strength, that exactly the moisture content, then in which way they are compacting. Sometimes when you keep the overburden for some period, because of their self weight, they start compacting. Whether that compacting is exactly making it as a self sustaining, that is your self stabilizing or not, that will be making. So these are the material characteristics and material behavior, how they will be behaving with water, whether in mix of water they will become a very flowable, or they are exactly going to be making a more sticky. That things also will affect how the dump will be stable. Similarly, that your mining equipment, if you are using a bucket wheel excavator, definitely you are bringing the material and by conveyor you are putting over there. But if you are doing it by shovel and dumper will be putting over there. When dumper and dozer will be moving over there, certain level of compaction will take place and they will become more stable. But if you are putting it by conveyor belt, then the material is not compacted, then whether you may be requiring another type of compacting over there. So these type of things are there, and then in the mining there will be lot of your blasting, that because of the blast vibrations, how your overburden dump is shaking, whether they can induce a failure to that. So these type of issues are there while maintaining a dump stability. So but to stabilize this slope, there could be a lot of things are done. You have seen, if you go to any mine site, you will find there is a physical reclamation is done. When we tell that physical reclamation, means a particular geometry is created, and then depending on the site, you may be saying here, suppose this figure is showing a gabions are placed over here, gabion just with a still where we are making a baskets, and inside that you are putting a stones so that they are become heavy, and then this is exactly at the toe portions you are giving a buttress so that the material do not slide down. Similarly, you will have to create a drains so that between two terraces the rain water that will have to be drained in such a way so that you do not increase the pore pressure to destabilize your the geometric design or that stability of the dump. So, there should be, sometimes they cover as a jute cover or sometimes geotextile cover they put it so that the erosion does not take place. Similarly, your that soil, it will have to be which is some manure you will have to place over there so that this grass can come over there, and that then the plantations will be done. So, you can see here how a technical reclamation is done, that overburden dump, it has created, say there is a drain there, you have got the slopes here, you have got the gabion here, and then the slopes over soil, and on that they have done the plantations, and that is in northern coalfield giant projects how beautifully they did it. But you cannot assure even such type of management under a very heavy climatic conditions, very heavy rain, this whole thing also collapses occasionally. So, that is why that you need to keep on monitoring, so that there should have been proper drainage system is very, very important. Otherwise, if water get accumulated over here or at the back side, they may create disasters. But you can see in another Nigahi mines that this type of dump, and they have got a retaining wall over here, and the dump is now totally vegetated, a naturalization has taken place. So, the land use that landform reconstruction is another way of how you are going to a stabilizing. So, that to stabilize the site you will have to a naturalization through forestry. That forestry development, it exactly stabilizes the post mining site in a best way, and for that there are different recommended approaches are there. You can refer this McDonald et al. That reference is given. This is a flow chart which you can take up for your mini projects or for your any field investigation, and you can do how exactly a forest restoration, forest built up can be there. This involves number of studies, but I have given you this flow chart taking from McDonald's et al. Because a such type of study are there, a need are there in our country, and a lot of places where we should replicate such type of study in which the whole topography will be modeled. Then we will have to create a particular landform, and then we will have to use the topsoil, and the topsoil will have to be properly developed, amended with the sometimes I said you before also how we used Pansagabya for amending the soil. Then soil and the nutrient recycling, all these things will be done. At the same time, your geotechnical stability, that stable site will be created, and then the revegetation will start, and this whatever the revegetation has been done, a small artificial forest will be coming, and the tree plantations will be done. Now, then you will have to align the topography to the next extent of it. When you have developed a manageable forestry, manageable greenery, then we will have to bring the concept of food forest that I have been telling you. The mining area, whatever the vegetation has been done, those vegetated area to be now created to a useful forestry, and there the food forestry, how the local food wisdom will have to be brought over there, and then we can create a food forestry. So, that is how the whole thing can be stabilized. Now, in the chemical stabilizations, exactly you will be modification of the soil properties by the addition of chemically active materials, like by if you are having a acidic soil, you will be giving some alkaline matter. If you are having an alkaline, you will be putting things that will be lower down the pH value. So, the chemical stabilizations will be necessary sometimes for dust control, for this road management, that is your, so that this, because if the there is no bondage in that, you use some chemicals so that the soil particle will be bonding together and you can make a road. So, that type of chemical stabilizations are done. So, this next is that your whole landscape planning. You can see in the mining sometimes a very good idea is that because this bottom here it will not be there. When you want to create a drain, there in the mining site maybe a lot of your old tires. Now using the old tires, on that you can put this your whole moram and other stones, and then putting over there, this will be very good your drainage pattern. And then that whole area there you can do this hydro seeding, a concept, and then with the hydro seeding and then proper drainage pattern, you can create a new landscape, and that is how the mining site will be transformed in a stable and self-sustainable site. Another example of your post-mining environmental care and stabilizing the area, that has in this one you can see an amphitheater has been created. So that means that area, post-mining area, you can see where there is the pit lake is there, the pit, all these construction sites were there, the mine, then some of the material all barren, everything is now that has been landscaped, and then they have created an amphitheater. They have now come up with a commercial units places, and this can be having a further the site is stabilized and also supporting the local community for other sustainable business. So this is the way how we will have to bring the post mining mine site will have to be stabilized physically, chemically, and a new landscape will have to be brought. The post mining landscapes lose their previous aesthetic, ecological, and your socio-economic values. So that's why we'll have to do that stabilizations physically and chemically and bring the stability of the post mining site. That this will require a lot of your careful analysis of the site. You will have to do a scientific study of it, and for that what is necessary, you must read. You read what others have done, how others have done. So I always encourage you to go through collecting the case studies, what others have done, then why cannot we do it, and we do it in a better way because we are Indian. So with that, I hope that you will be taking up the case studies to do something good. Thank you very much.